Awesome. Sounds good. And I've got two monitors, so if I'm staring in another direction, I'm looking over at everybody's faces over on the other side. All right. So first of all, thanks for having us. My name is Ben. I work for the county's Department of the Environment. I'll get into a little more about who I am and what we do in a little bit. But when John and Alan asked me to present, I naturally thought of Tim, who is the culvert expert. So I'm really happy to have him here with me today. So I don't know, Tim, you want to say hi?
Hey everyone, thanks for having me. Hope you're having a good evening.
Awesome. All right, so let's jump in. We want to just do a quick introduction of who we actually work for. So I'll go first. The county's Department of the Environment. We've been around for about 12 years, and really our role is coordinating environmental policy and planning across the county government. We have expanded our role quite a bit in the last couple of years. Our staff has doubled. We do a ton of work. I've listed a few of the projects that either I or my colleagues work on here. Yeah, it's a lot of work. It's a lot of fun. We're doing more municipal work, which is really exciting in the last couple of years, kind of bringing in money and funding and support for these projects for municipal support where we think our support's needed. So that's Department of the Environment. I'm going to turn it over to Tim quick to talk Cornell Cooperative.
Yeah, so I am with Cornell Cooperative Extension of Ulster County. If you're not familiar, Cooperative Extension is part of the land grant university system. So that's a federal law that put that into place. And so every county within New York State has a cooperative extension office. And, the role of extension is to respond to local needs with unbiased research-based information. And so we have that connection to Cornell. And what we try to do is take a lot of that academic research that's coming out of Cornell and other universities and make it applicable to the residents of our county. So we have that sort of local focus. Similar to the Department of Environment, we have our hands in lots of different pots, all sorts of youth and family programs, and responding to contemporary challenges. So, we've done a lot of work on the opioid crisis in the last couple of years. Obviously, with that land grant connection to Cornell and their agricultural school, we do a lot of farm programs, developing pest-resistant crops, and then trying to get local food into schools and boosting urban agriculture. Provide services for veterans, small business. Probably most people have heard of 4-H. That's run through Cooperative Extension, the Youth Development Program, our Master Gardeners Program, and then we have an Environment Department. And so I solely work in the Environment Department. I don't really know a lot about the other stuff that my colleagues work on. But within that environment, we're involved with a lot of the climate smart planning. We're part of the New York Sea Grant. And then in Ulster County, CCE works with the Ashokan Watershed Stream Management Program, which is a collaboration with Ulster County Soil and Water Conservation District and the DEP to do stream management in the part of the county that drains to the Ashokan Reservoir. So recently we've gone under some staffing changes, and I used to kind of be cloistered away in the watershed, and I'm now starting to be able to get out and take a lot of what I've learned in the watershed over the last 5 years and extend that, and hopefully the benefits that come from that to the rest of the county. Very glad to be here.
Yeah, Tim, that's something that we are really excited about. Our both of our programs are pretty closely related, so we work closely together pretty frequently. All right, so we're going to jump around a little bit in the beginning here, but I just want to set the stage just to give you all some context of why we're working on this. And the first thing that came to mind is the county's Green New Deal. And so we work at the county scale, and the counties are a good interface between state and federal governments, and then the municipalities where everybody lives. We're pretty well suited to doing kind of larger scale work. The three main goals of the Green New Deal involve clean energy, equitable green economy, and conserving natural resources and building resilience. And this is where we come in. Up in the yellow boxes here, we have a 2025 goal in that plan of completing an inventory of road stream crossings in need of repair and resizing. So that kind of is a solid work plan for what we're doing with these projects that we've got. So that comes to me. A little more about me. I do a lot of road stream crossing assessment work. I'm also managing the county's natural resource inventory, which I'll talk about towards the end of this presentation. I am currently a Master's of Science student for Geospatial Science, or GIS. We were talking a little bit just before we started, but I coordinate the county's MS4 program. I also co-coordinate the Water Quality Coordinating Committee. Our department's the county's water quality management agency. I write grants and I manage those. I do a lot of work in GIS. And I come from a background in water quality monitoring. I did a lot of work on the Hudson River over at the Hudson River National Estuarine Research Reserve. All right, so just a quick primer on watersheds to set up the stream talk. Here we see the Rochester Creek draining into the Rondout watershed. So watersheds are defined by points. And at that point, all the area that drains to that point, you could call a watershed. And the watershed characteristics basically form usually streams. And streams, we like to look at as linear features, right? So streams are linear networks across the landscape. As they flow, they interact with things. We can see here just some streamlines on a map. We also see some roads. Roads are also a very long linear network. And so where they intersect, we have a road stream crossing. They're everywhere. You're probably familiar with bridges and culverts. And so before we move on, I did want to note a distinction because I also work on stormwater. There are differences between stormwater infrastructure and road stream crossings. Stormwater infrastructure, also usually culverts, ditches, outfalls. Stormwater infrastructure is strictly for the purpose of channeling water away from impervious surfaces and into surface water, not streams. We get confused in the field all the time because they interact all the time, with stormwater draining into streams, and then you've got culverts everywhere, and it can be difficult figuring out what's what. But I did want to just make a note that we get questions all the time. If you're mapping culverts, really, what does that look like? Well, we're specifically for this talk and some of the projects I work on, we're talking about streams, and Tim will get into streams a little more. All right, so road stream crossings, what's the big deal? Why are they so important? Well, first of all, they're everywhere. There's an organization called NAC, which predicts over 4,000 road stream crossings in Ulster County alone. This is a big deal because every road stream crossing can present a barrier to a stream. So picture 4,000 potential barriers to streams just in Ulster County, and it kind of paints a pretty bleak picture if everything is in bad shape. So let's first talk a little bit about aquatic connectivity, which is that acronym up on your screen. Is the North Atlantic Aquatic Connectivity Collaborative, which is one of the protocols that Tim is going to talk about in a little bit. But I really like this photo because you can clearly see a stream, and the pipe in the foreground is supposed to funnel that entire stream across the road and continue it on its way. And so we see here a big outlet drop, a very large scour pool, and a bunch of erosion. And I'm not going to steal Tim's thunder, but what this really does is it's a big disconnect. And so all of the upstream habitat is disconnected from the downstream habitat. That's a big deal for fish and other aquatic life, but it's also a big deal for all the terrestrial animals and critters that use stream banks as transportation corridors, which happens really frequently. Okay, so now that we know road stream crossings are everywhere, and we kind of have a picture of why they're important for aquatic life, let's back it up a little more. So streams and road stream crossings really need to intersect, because road stream crossings are a conduit for flow. And when they're not passing water efficiently, they can serve as hydrologic plugs in the system. You can see in this picture, we have a pretty large bridge, but we can tell it's undersized. It's backwatering, which increases flooding upstream and also increases force on the structure and the road itself. This is no good because of climate change. We're going to back up a little more till we dive into some specifics, but let's talk about our changing climate. And climate change is a really complex topic. And the one relationship that I want to talk about is heat and moisture. And so you can see on the screen, for every 1 degree Celsius increase in temperature, we see 7% increase in water vapor availability in our atmosphere. That is the connection between larger storms in the future. And so when we have more intense storms, we have more rainfall, and our infrastructure is aging. It's undersized. It was built for storms that are much smaller that we typically saw in the past. And this is a big deal because we're seeing the effects of climate change now. And climate change, right, is all about pushing the extremes of what we know and what's the norm. So this is just a fun graphic that I pulled yesterday from some NOAA data. And you can see that yesterday we had 15 million people under flood alerts. And at the same time, we had 115 million people under experiencing drought, right? So we're pushing the extremes already. And when we think about our aging and undersized infrastructure with these more extreme climate events, we get what we all love to look at, but kind of hate to see, is just carnage in our environment and our systems. Which is no good. I mean, it's a big threat to emergency responders. It's a big threat to human life. It's really disruptive. It's bad for the environment. The list goes on and on and on. So this is Irene up in Shandaken. I'll go through one more example. This is up on County Route 47, just to get a sense of the scale of what we're talking about. You can see the culverts that were under that road about 100 yards down into the woods. And so it's really important for us to do this work so that moving forward into the future, we can really begin to build and plan for future storms and the impacts that we will see. And so you can see here that this is the Cascade Brook Bridge that went in where that culvert was. And you can see kind of the impact and just the size and how well that would pass the future flow. And so that really kind of gets back to my role and what we do and what Tim does up in the watershed, is that at our level of work, at the county or watershed scale, we go out and we try to get funding, and we go through this process where we assess and we plan, and then we try to design for the impacts that we will see in the future. And so these are the two big projects just in the last 3 years that I've managed. And I've worked very closely with Tim and a number of other partners, and we have received some good funding for these projects. But that's kind of the overall picture that I want to paint as far as importance, now and moving into the future. And I think with that, I'm going to turn it over to Tim. Tim is the real culvert expert, so I'm going to let him take it from here.
Bet you didn't know you could be an expert in culverts, but yeah. Regarding some of this culvert work that's going on in Ulster County and the work with Ben and the Department of Environment, my role in some of this work is as a technical advisor. So Ben is miles beyond me in terms of his GIS capabilities, but I have a very sort of small niche, which is really stream mapping and road stream crossing mapping that I've developed some methods for. So I help Ben with some of that. The real meat of what I do is the field assessment methods, and we're going to get into some good detail on that in a little bit, and then how to take that assessment data and create scores and ultimately prioritization lists. So, there's 4,000 crossings in the county. Where do you start? And like Ben said, I've kind of been doing this for a while. I did my master's research on road stream crossing mapping at SUNY ESF, did some work with the Nature Conservancy, doing culvert assessments up in the Adirondacks, which was a great way to spend a year. And then since 2018, I've been with the Ashokan Stream Management Program up in the New York City portion, the New York City watershed portion of Ulster County. And then since 2020, I've really been working with Ben to take some of this expertise that I've learned over the years and spread it throughout the county. So that involves this new Green New Deal project, and then implementing what's called the MOSCAP. So it's a multi-objective stream crossing assessment protocol. And so Ben, you can go to the next slide. So this is really where I come in, is we have all of those culverts to assess. And, so how do you do it? There's lots of different ways to look at culverts. There's lots of different things you could potentially measure. So this MOSCAP is something I developed over the course of a couple of years. It was piloted up in the Watershed, and then in 2020 started working with Ben. And so, like I said, it's sort of like this culvert management framework. There's a couple of different parts of it that starts with that GIS work, like the image that Ben showed is, predicting where these crossings happen. We have stream maps, we have road maps, we can kind of get a good guess as to how many crossings there are, where they are, how big they are, without ever leaving the office. The big part of MOSCAP is once you do leave the office and you're in the field, it's a robust and sort of holistic assessment method. So you're looking at a bunch of different aspects. So aquatic organism passage, like Ben talked about, geomorphic compatibility, which we're going to talk more about in a little bit, the structural condition. So, what is the physical condition of the crossing structure, whether it be a culvert or a bridge, and then this idea of flood flow capacity. So how much water can each structure pass, and is it enough? And is it enough in the face of climate change too? So we have a specific model that looks at that. And then again, once all that data is collected, it presents a customizable prioritization framework. So depending on what your interests are and potentially where your funding is coming from, you can prioritize your culvert inventory in a way to match those objectives. All right, next slide, Ben. So the idea is, that road stream crossings, it's a pipe under the road. Most, like the introduction said, most people don't think about it. Most people don't even know they're there until they fail, ultimately, which is why we show these sort of carnage pictures, because this happens, and this happens locally. So this is another one. As you can see, the elk bushkill up in Shandaken just got destroyed during Tropical Storm Irene. The idea behind MOSCAP and using MOSCAP throughout the county to meet the Green New Deal objectives is that we want to create good, resilient crossings. And good, resilient crossings allow the road to function, and they allow the stream to function, and they allow both of those to function across a range of conditions. Low traffic conditions, high traffic conditions, low flow conditions, high flow conditions. So, that's a nice sentence. We want to allow things to function, but what does that actually mean? So next slide, Ben. What are the functions of a road? And if you think about it from the perspective of a road stream crossing, what impacts could a stream have on a road that would make it so that that road is not functioning? You can do next, Ben. So this is kind of easy. Roads are for traveling on, they're for vehicles. But you dig a little deeper, like we've talked about, you need roads to deliver emergency services. And that's one of the responsibilities of local government is to provide emergency services for their residents. And then also in the case of an emergency, how do you get out of danger? You take a road. So next, Ben. So really what we expect of roads is that we want them to be functioning when we need them. And it's often when we need them, which is when they're not functioning. And that obviously creates problem. You know, up in the watershed in parts of Shandaken, people were cut off from emergency services. They literally couldn't get out. People were walking out of some of these hollows covered in mud with suitcases. And, you know, that's just unacceptable. So that's the functions of a road. The harder question, and you can go to the next slide, Ben, is what are the functions of a stream? What do streams do? And from the perspective of a road stream crossing, what could a road do to a stream that makes it so it doesn't function? And so I do want to sort of ask the audience, you can unmute yourself or you can chat, but can anyone give me an example of what streams do, what functions they do, and like what we expect of them? Does anyone have any ideas?
Yeah, they support fish life and transportation for human recreation.
Yeah, absolutely. So we've got sort of fish, they provide aquatic habitat and are a linear transportation system, like Stuart was saying, for not only aquatic animals, but riparian species as well. There are more. Can
I could throw out one. I think probably streams and watersheds are probably the foundation of all life on the planet. So I think they're important to have those corridors.
That's a big one. Yeah. Water is the foundation of life. And so Ben, I'll go to the next slide. And you can actually click one more. So water is the foundation of life. And really, when you think about a function of a stream, it all begins with the water. So this is what we call a functional pyramid, where each layer of the pyramid sort of depends on the stability of the one below it. So ultimately, in terms of stream functions, you know, it's not hard to envision why hydrology, why the water is the foundation of it. And then you can click next. Another function is the biology. So there we go. We've got sort of the water and the life in the water. And that, you know, I've given sort of similar talks to this for many years now. And I'll tell you, like 99% of people, it's water and fish. And that's mostly what people think about, which, you know, is fine. And those are very important functions. But as you can intuit, I'm sure, you know, there are some things in the middle that biology depends on. It's not only just the water. Ben, you can do next. So between the hydrology and the biology, we have a bunch of other things that kind of get a little complex and often overlooked. But we have hydrology at the bottom, which is like, it rains on the landscape and that water eventually makes it to its way to the stream. Once it's in the stream, that water is moving in sort of very complex and important ways. It's called hydraulics. The hydraulics then determine the geomorphology, which is the shape of the stream channel, really, and how the stream interacts with the landscape. So why do streams look the way they do? Why are some streams straight while some others are very sinuous, very meandering? Some streams are steep while others are very flat. You know, that's geomorphology. And then that interaction between water and sediment gets into this physiochemical thing with nutrient cycling and, you know, algae formation, photosynthesis, like all this other stuff, dissolved oxygen content, which is super important for fish. So there's a lot of stream functions and a lot of them get overlooked. Next, Ben. So you can go back one. So yeah, things from the perspective of a road stream crossing again, most people think of fish and floods, so biology and the hydrology. But a good crossing, a resilient crossing, one that allows the stream to function, is one that allows water and sediment to be moving through the structure, because a functioning stream is one that's in this state of dynamic equilibrium. So if you think back to your like high school earth science class, which I hope everybody took, you may have learned that like streams are always changing. You know, they're changing location. Maybe you've seen some of those maps of the Mississippi River as to how it's changed courses over the last couple thousand years. So streams are changing, but they're also in a state of equilibrium. So they're eroding and they're depositing and they're doing all this stuff all at the same time. And a good resilient crossing is one that accommodates that. And so this is sort of the expertise that I've gained over the years doing this, is this idea of this intersection of geomorphology and road stream crossings and dynamic equilibrium. And now we can go to the next slide then. That study, the study of how streams interact with the landscape, is called fluvial geomorphology. Fluvial just meaning it's moving water, a Latin word for moving water, and then geomorphology, the shape of the landscape. So how streams affect the shape of the landscape. There was a very famous fluvial geomorphologist who was the son of Aldo Leopold. I don't know if anyone read Sand County Almanac by Aldo Leopold, a great sort of environmental classic book. His son, Luna, was a pioneering geomorphologist and a really awesome looking guy. So I think I've got a picture, Ben, if you click next, you know, kind of stream cowboy. But he had this quote that the river is the carpenter of its own edifice. So, you know, if people disappeared from the earth tomorrow, streams are going to continue doing their thing, transporting sediment, shaping themselves. So humans, you know, in some sense have zero effect on what a stream is going to do. And the way a stream shapes itself is primarily through two processes, one being erosion, which you can see some extreme examples of here, again, from Tropical Storm Irene. And the other main process is deposition. You can go to the next slide, Ben. And again, some extreme examples. If anyone's ever been in an area after a bad flood, what you notice is that there's rocks and there's mud and there's sediment everywhere. And it really gives you a clear picture of sediment transport and that geomorphic function of streams and how important it is and how devastating it can be if it's not accounted for. So that, and then there's that phrase dynamic equilibrium. So these processes are occurring, deposition, erosion, they're all kind of happening at the same time. And in a stable stream system, those two processes are in balance. So that's how you can have it be dynamic. You know, things are changing, there's erosion, there's deposition, yet also be in equilibrium. Where there's erosion, it's equally counterbalanced by deposition somewhere else. And that's how you get a stable stream. So you can go next, Ben. And we have this sort of very conceptual, simplified model of what dynamic equilibrium is, where you have this relationship between water and sediment. And it's this very sort of finely tuned scale that a stream, if given infinite time and infinite space, it will eventually stabilize itself. Now, if something changes, if the climate changes, if land use changes, if over geologic time there's geologic uplift and the stream slope changes, things start to happen. So you can, next, Ben. So say, for instance, we start to get a warmer, wetter climate, which is kind of what we're expecting in this area. That tips the scale and it sort of pulls the water side down, and we get what's called degradation of the stream, or an imbalance in favor of erosion. So we're no longer balanced between erosion and deposition. We're getting more erosion than we're getting deposition. That's kind of what we're seeing with this, you know, massive stream bank erosion, down cutting or incision of channels, which is when the stream bed erodes and it sort of starts to drop. On the other side, next, Ben, you can get what's called aggradation. So you have too much sediment, not enough water, which can happen when you have like a huge failing hill slope that's just pouring sediment into the stream. All of a sudden the stream doesn't have enough power to move it, and you get aggradation, and there's a slew of impacts that come from that. So that's sort of a streams 101 kind of discussion. Next, Ben, in the sense, going back to MOSCAP and this idea of looking at culverts and bridges holistically, where yes, we've got aquatic organism passage, aquatic habitat fragmentation is a really important thing, especially in Ulster County, where ecotourism is a real driving economic factor. We have the flood flow capacity. So if you remember the bottom of that functional triangle, are these crossings sized for the size floods that we expect to see? There's obviously the structural condition, is the concrete crumbling. But what's kind of unique about MOSCAP is this geomorphic compatibility module. And that's going out into the field, looking at the river, thinking about those river functions, and looking for specific manifestations of those processes, which can get kind of difficult. But this is really like, this is my bread and butter. This is the stuff that I love to do. So part of like the way that we do this, we'll go through some examples. So like I said, we have those primary processes of erosion and deposition. So in a MOSCAP assessment, one of the things that we measure qualitatively is erosion. So Ben, you can go to the next slide. But it's not only erosion, whether or not there's erosion happening, it's the degree of erosion, it's the context, are we upstream of a crossing? Are we downstream of a crossing? Are we on the outside of a meander bend where we'd expect to see natural erosion? Or are we somewhere where we wouldn't expect to see natural erosion? So there's a lot of context that needs to be thought of when we're going out and doing these assessments. Next slide. The counterpoint to erosion is deposition. So are we seeing signs of excessive sediment deposition, which is telling us that the scale is out of balance? Believe it or not, there's half a dozen different types of deposition. And depending on the type of deposition that you're seeing, it can, again, give you context. Like, what is the river telling you? What's going on here? Again, are we on the inside of a meander bend where we'd expect to see that point bar deposition? And then how much deposition? Are we getting these huge bars that are inside of a culvert? Because if we are, we're reducing the hydraulic capacity of that structure. The structure fills in with sediment. The next time we get a flood, there's not going to be any space for water. Where's the water going to go? Over top of the road. So there's a couple other things that we also look at. Go to the next slide, Ben. So one of the things is scour. So again, I think I mentioned that term, but scour you can think of as erosion of the stream bed. So the rocks, the sediment, the material that's making up the stream bed is being carried away faster than it's being replaced. So on this picture on the right, you can see that there's so this is the footer of a bridge. So there's this is the abutment, there's a bridge laying on top of this, but there's about a 6-inch gap between the bottom of the stream and the bottom of this bridge abutment. So really this bridge is kind of floating in some sense, at least on this side. And we've used these stadia rods that are like 6 feet long. And I was able to shove that thing like 4 feet back underneath there. So that's telling us that the stream bed is being scoured underneath this structure, which is, not a good sign. On the left here, you can see a similar thing where on this culvert, material of the stream bed has been scoured away. So now, rather than going into the pipe, the water is actually going underneath the pipe. And you can kind of imagine how that might be a bad thing, where that's going to undermine that culvert and ultimately lose its structural integrity.
Excuse me, is that the uphill side of the upstream side of the pipe? Or?
Yep, that's the inlet.
Inlet.
Yeah, so as water's approaching that structure, it's able to just kind of like bypass the culvert and go around it.
Right.
Yep. So another thing we look at, next slide, Ben, is the alignment. So, is the stream coming in straight? Is it coming on at a 90-degree angle to the road? And if so, is it naturally straight or has it been made that way? And so there's some sort of subtle clues that we look at. So on the left, we have a naturally straight stream. On the right, we have one that's called channelized. Over time, these riprap boulders have been placed along both banks. So it's not really a natural functioning system in that sense. Next, Ben. And then we have ones that come in, I've seen some that literally come in at a 90-degree angle. And if there's something you should know about water, it's that it doesn't want to go at 90-degree angles. So, generally we have this threshold of 45 degrees. If the stream is coming in at an angle greater than 45 degrees, really bad sign. It's just not setting either the road or the stream up for success. Next, Ben. To go back to Ben's point about watersheds, watersheds are important because it can tell you a lot about the stream. So another thing that we look at is there a break in the slope of the valley? So is there a difference in the slope of the watershed? So here on this blue line, you can see it as it comes from left to right. Those topo lines, the contour lines, are really, really, really close together until you get to about 500 feet elevation, and boom, it flattens out. What happens in a scenario like that is as the stream's rushing down this mountain, it has all this power, it's able to carry all this sediment, and then it hits that flat area and it loses that power almost instantaneously, and it drops out all the sediment. And then if you look, a couple hundred yards further downstream, we have a bridge. So that is really going to impact sediment transport, geomorphic compatibility at this site. So it's a good thing to know, if this is the case. So these are some of the things that we look at. And you can go to the next slide, Ben. Like I said, this is really what I like to do. So it gets very technical. It requires a trained and a calibrated eye. But that's one of the things that I do and I really like doing is we host trainings on this MOSCAP procedure. They usually take about a week because we have classroom sessions and then we go out in the field and we try to find structures that run the whole range, both in terms of road function and in terms of stream function. So this past year, we held a pretty large training in 2022, and we had representatives from DEC, the New York State Department of Transportation, New York City Department of Environment or Environmental Protection, and Soil and Water Conservation Districts. Back in 2020, I trained Ben in this protocol and some Department of Environment staff that surveyed, Ben, 360 crossings using this procedure, something like that. And then up in the Ashokan, we've used this process for over 600 crossings. So at this point in Ulster County, we've used this MOSCAP, this sort of holistic assessment method, for over 1,000 of those 4,000 crossings. So it's really kind of exciting, and it's unique in that way. And Ulster County really sort of has higher quality data than most of the rest of the state, if not the country, in terms of their culvert and how it affects management. Next slide, Ben. So we collect all this data. We have these different assessment objectives. That third part of the MOSCAP is, okay, what do we do with that data? How do we make it useful? And the way that we do that is there's a whole book about it, if you want to dig into it, but it's very customizable. So ultimately what you end up with is 4 assessment objectives: your aquatic organism passage, geomorphic compatibility, structural condition, and then your flood flow capacity. What you then do is you take those 4 objectives and you say, okay, which one's most important to me? Is it aquatic? If I'm someone from Trout Unlimited, maybe I'd say, aquatic organism passage. That's my primary objective. If I'm a highway superintendent, structural condition and flood capacity, those are going to be my primary things. Up in the watershed where we have this concern about turbidity and fine sediment, geomorphic compatibility is the biggest issue. So one of the really neat things about MOSCAP is this customization ability to change those scores. And you basically just punch in your scores and then it gives you a prioritized list. You get a numeric score and then it also bins it into these different categories. What's neat about the upcoming project that I think Ben is going to talk more about is this customization extends beyond these 4 assessment objectives, and we can put in other important factors that we want to integrate into that score. So things like road criticality, is how many people are going to be cut off if this road becomes impassable. Stream order, so bigger streams, bigger crossings, there's fewer of them, but their impacts tend to be larger geographically. That one picture of the bridge that was backing up that Ben showed, that likely had a significant impact hundreds of feet upstream. If you're on a tiny little culvert with a tiny little stream during a flood, maybe your road's going to get overtopped. It's probably not going to get washed out, and it probably will be passable in another couple hours. So everything's sort of relative to that stream order. And then, lots of other things could be incorporated into this scoring strategy. So we've assessed, we've scored, we've prioritized. That's great, but like the next step is really, how do we use this to improve resilience in the face of climate change? So once you're able to get past this assessment stage and prioritization, the next step is to find the crossing that you want to replace and start to work on it. If you want to do it right, you're going to put some thought into it. You're not just going to take a pipe from the back of the yard at the DPW and throw it under the road. So it really takes some planning. Ben, next slide. So how do you design a good road stream crossing? At the Ashokan program, we have this sort of design review stage that's worked really well for us. And we call it the 30-60-90 review. So generally you hire an engineer to do these designs because it gets very technical. There's a lot of calculations that need to be done. But rather than just say, hey, engineering firm, here's $20,000, give us a crossing design. We say, hey, let's meet at various stages along the way to make sure that we're all on the same page and that nobody's sort of losing touch with our project goals. And so the first step is this conceptual design or a 30% design. And this is generally, saying, here's our priority. This is why it's undersized. It's not passing sediment. It's a barrier to aquatic organism passage, and it's a big flood hazard. You figure out who's involved, who owns this property? Who do we need to get on board if we want to do something about this site? And then back to our stream function pyramid, it all starts with the hydrology. So you do a hydrologic analysis. How much water are you going to expect to see here? A lot of times you have to meet certain design standards. So if it's a DOT, if it's a state-owned road, they require that a new crossing has to pass the 100-year storm. So you need to have a pretty good estimate of what that 100-year storm is to be able to design a crossing that way. You do some preliminary hydraulic modeling to make sure that that structure is going to pass that flood. And then ultimately, the end point of a conceptual or a 30% design is how much is this going to cost and how long is it going to take? So what we do is the engineer comes back to us at this stage. We go back and forth, we double check their hydrology, does 561 cubic feet per second sound right for a recurrence interval? What data did you use to get that? Once everybody is confident with that 30% design, we go on to 60. So next design, Ben, or next slide. Oh, no, sorry. So this conceptual stage is really when you can try to integrate what's called best management practices. So what would the ideal replacement crossing look like? Ideally, what most people are pushing for nowadays is to have a structure that has a natural stream bottom. Clearly, it's going to be better for fish. It's going to be better for macroinvertebrates that the fish eat. And it just makes it a more natural system if you have that natural stream bottom rather than a plastic pipe or a concrete box. If you can't have an open bottom, it's best to embed that structure with native stream bed material. We want to make sure the structure is wide enough. This 1.25 bankful channel width is a DEC recommended guideline. So, ultimately, the best management practice is to have the stream still look like a stream as it goes through the crossing. And this is a pretty good example here from a structure we did in Olive on Upper Boyceville Road, where inside the structure, the stream looks an awful lot like it does upstream. That's a good crossing. So at this conceptual stage is really when we try to hit these target objectives as much as possible. So next slide. So the 60% design, again, we touch base with the engineer. We've typically settled on a preferred alternative, an open bottom culvert or a concrete box culvert, whatever it is. We've decided on that. There's more intensive, more specific modeling that's done. The engineer typically starts to do this earthwork analysis, how much grading needs to be done, cut, fill, what's the construction sequencing, what are the permits that are required, and then let's put this out to bid, holding to whatever procurement guidelines the municipality might have. And then a revegetation plan. Vegetation is super important on these sites as they recover from ultimately what's a surgery. I like to think of culvert replacement as a surgery, and it's an invasive surgery. So planting really helps to recover after that. Next slide, and then we get to the final design. So this is what the construction firm uses to actually build the project. Then it goes out to bid for construction. And so that's typically how we have done design up in the watershed, and we've had good effects. Next slide. So here's another example on that Upper Boyceville Road culvert. So the left is what it looked like. It was severely undersized. It was a barrier to aquatic organism passage because it had a flat concrete bottom with no native sediment, and it had sheet flow, which is notoriously hard for fish to move through. And in the picture on the right, the person on the left there, that's Brian Burns, the town highway superintendent for Olive. And we're looking at this culvert after a high flow event. So you can see all this sort of leafy material up in here. That's sort of been left over after a high flow. It wasn't quite a flood, but that flow would have overtopped the road with the old culvert, according to Brian. But it went through this new structure with flying colors, no issue. Next slide. So the sticking point really is, how do we get from assessment to assembly? And that's what everyone is trying to figure out at the moment. You may have heard that there's a big infrastructure bill that was passed at the federal level. So this isn't only an Ulster County issue, it's a national issue. We have aging infrastructure and we have climate change. So, and every county in the country has thousands of crossings. So this is, it's really starting to get attention, and it's starting to get the financial support that it needs to provide a benefit to communities. So, some of you might be thinking that 30, 60, 90 review, oh, well, that's going to increase costs. Absolutely right. But as anyone that's sort of planned a family budget, or any type of program budget, sometimes an increase in upfront costs is made up for in long-term savings. A hard political point to sell, especially when you're talking about municipalities with limited budgets, but something that we ultimately push for and that we're getting the data to back up. Another thing that we've run into, especially in the towns of Shandaken and a little bit of Olive, is you get some of these grants, like from Bridge, New York, some of these other state and federal grant programs, and the administrative burden that it puts on communities is just out of this world. The amount of paperwork, the amount of procurement stuff that you have to go through. And that's really been a barrier to improving road stream crossings that we've seen. You also need to have someone there that makes sure that the project is constructed the way it was designed. That person has to be paid. That's additional costs. But for the communities in Ulster County here, you're lucky in a sense in that you have a lot of technical resources available through the expertise that I've gained over the years, and then also my counterparts at the Soil and Water Conservation District of Ulster County, which sort of put me to shame in terms of their technical expertise around this. And then a good project is one that's monitored. So you don't install it and construct it and just walk away. Someone should be going back after the flood event. Hey, is this structure that we just invested $100,000 in, is it performing as it was designed to? And that's a really important part of this. And so that was a lot of information, but thank you. And I'm going to turn it back to Ben there. But yeah, thank you for letting me share the MOSCAP and what I know. Back to you, Ben.
Awesome. Thanks, Tim. I've just got a few more slides and then we'll wrap up. So continuing this discussion, we've heard a lot about road stream crossings, a lot of technical information, why they're important. And we're finishing with, they are expensive to replace. But backing up, we have all of those steps that we've talked about. We have the assessment, we have the planning and the design, before we really need to go out for funding. And so I want to talk a little bit about the planning step, and Tim and I were talking and he had a great line that like when plans converge, that's when you get really great funding opportunities. So when we go out, we do our assessment work, say we do design work, we prioritize these projects. If we can document those projects in multiple plans, that serves as a great foundation, and some really great funding opportunities can come from those. So that is kind of like where we're headed in a lot of this work. And so I'll just wrap up with a shameless plug on some of the projects that we have going on at the county level that can really help, municipalities and other groups kind of push for these replacement projects. And so the first and probably most relevant one is the county's hazard mitigation plan, which is currently going through an update. And municipalities can elect to participate in this. The assessment work that we do really just tees projects up for inclusion. And if your municipality is in the hazard mitigation plan with a specific road stream crossing as a priority, you open yourselves up to tons of state and federal funding and emergency funding when storms happen. So as you're working with your municipalities, definitely encourage participation. And if you want more information, get in touch. Some of my colleagues work very closely on this project. Another extremely relevant one, I did want to talk about our upcoming project. We were recently awarded funding from NUIPIC and New York State DEC to keep going on this work. So we're focusing on finishing the municipalities in the lower Esopus watershed. And at the conclusion of the project, all of the lower Esopus towns will have 100% MOSCAP assessment coverage. But the real kicker here is that at the end of this project, we're going to have a countywide road stream crossing mapper. So as we go out and assess crossings, the mapper will just score them for us, and this will be publicly accessible and hopefully a really great point on engaging with the towns and watershed groups and ECCs and CACs. So this Woodstock 2 site, just real quick, is a really good example of this process where we assess, plan, design, and replace, because we found that this was a priority during our 2020 assessment work. We wrote a whole bunch about it in a plan. We actually ended up with final engineering designs for it, and it's being replaced next year, which is going to be a really exciting project. We're currently, it's in the county's capital budget, but we are trying to get additional money for it. All right, so I'll fly through these. Tim mentioned transportation criticality. So this is a project that is being managed by our planning department, and basically looking at our transportation network and determining our vulnerable segments, looking at essential facilities, population density, evacuation routes, transit corridors, et cetera. This will also be a web map, publicly accessible. and really kind of shapes our priorities in terms of assessment work for road stream crossings, because they're a big component of our transportation system, as we've learned. The next, we're working on a big climate adaptation planning project, and similarly to the transportation criticality work, we're really focusing on where our essential facilities are and what climate hazards they will be facing in the future. So here's just a really quick example of the town of Rosendale. We see a fire department, a library, and a wastewater plant all within the 500-year floodplain, which is projected to become a much more frequent flood in the future. And the last one, another shameless plug. This is my project. I'm working on the county's NRI. And so once we get our road stream crossing mapper, you will have a great road stream crossing layer in the NRI, because like that's the intersect between kind of human culture and our natural water systems. So looking forward to continuing on that. We'll have a lot of public engagement. We'll have presentations to the Environmental Management Council, the Climate Smart Committee, and then we'll have a couple public workshops and then a municipal training session at the end. So I just wanted to wrap up with this quote from the co-founder of ESRI, just to kind of give ourselves hope that the work we do isn't totally kind of meaningless and in a vacuum. And, hopefully Tim and our colleagues and you all are actively working towards this sustainable future, because, we do have a lot of unknowns, and it's just all about, what we can do now to plan for the future. So with that, I will wrap up. And I think we might have a couple of minutes for questions. So I can turn it back over to.
Yeah, it seems like a lot of people are talking about this bridge in Accord. Are you guys familiar with that one?
Let's see.
Over the Mombacas.
Yeah, over the Mombacas is huge. Everybody's, it's like people call it the Skyway or something. Any ideas maybe why it's so big and high?
So Tim, I know a little bit about this project. This is where 209 was elevated, right outside of Accord. I don't know if you've driven down there recently, but the crossing, it used to flood all the time. 209 went up, I don't know, 20, 30 feet maybe, but it also crosses over the Mombacas Creek. And actually, Tim, this would be a great site for you to go check out, because I think upstream and downstream, there's just like tremendous buildup of woody material now, and a lot of changes to the stream. So I don't know if anybody's looked at that on our end, but.
So you're just wondering why the structure is so big?
Well, is it effective on what they've done? And it seems overkill to me, to a lot of people. Do you have any thoughts on that?
Yes, some, like, I know this is a really strange area because 209 is right along the stream, and then the stream kind of bends away, and that's where Mombacas Creek comes in. So, like, if you think back to that hydraulics discussion, so what happens is, the rondout is running along 209, and then it starts to bend to the right, ultimately away from 209. And that's right where Mombacas Creek comes in. So if you might remember from high school earth science, where it's like the water moves faster in the pools as it goes around those bends, and that's kind of why you get erosion. So at confluences, you get this weird interaction of hydraulics. And so what I'm guessing, and I haven't been there in maybe a year, but when you have a smaller stream that's entering a bigger stream, if the bigger stream is in flood stage, it can actually backwater the tributary that's coming in. So the tributary is coming in, and it's sort of hitting a wall almost, because if the rondout's in flood stage, it's overtopped its banks, and it's starting to spread out onto the floodplain. That floodplain also happens to be the channel of the tributary coming in. So the water starts to slow down in the Mombaccas long before it actually reaches the Rondout. So it's not only that you have to calculate like, okay, what's the 50-year flood on the Mombaccas Creek, but you also have to say, okay, well, if the Rondout's already in flood stage and we have this 50-year flood coming down the Mombaccas, you have this synergistic effect where like the two are adding. So you might think it's overkill, but the next time the Rondout's in flood stage and you're getting floods from the Mombaccas, it might not look so much like overkill. That's a big, expensive project. So I'm assuming there was some good hydraulic analysis done that gave them those specifics. Like if you think about it from an engineering and construction point too, why would you build something bigger than you needed it to? It's going to cost more.
Yeah.
So that's my take. Like I said, I wasn't involved with the project. I don't really know the flood history of that area. But that would be my sort of 2 cents.
Makes sense.
Michael has his hand up. Michael, do you want to unmute yourself?
Yeah, very good presentation, Tim. And I'm curious to know if you were to grade the current county culvert infrastructure, what would it be?
As a whole, like as a whole county system?
Yeah, and then I'm going to ask you on the state and federal level too.
I'll tell you once we assess about what, Ben, 3,000 more crossings.
A lot.
Yeah. There's a lot that haven't even been looked at yet in this way. All the municipalities I've found generally have a really good grasp on where their problem areas are. And what they
Are
can
you
do.
of the 1,000 you've looked at, are you finding a lot of problem culverts at this point?
Yes. And everywhere that I've done culvert work since 2014, when I was in grad school, the problems are not, limited to Ulster County. This is an issue that, like I said, everyone's dealing with. So some places are better than others. Really what we're pushing for is to get Ulster County to be better than the others, especially in the state. But yeah, everybody's hurting, budgets are strained. So, but every highway superintendent I've ever spoken with knows that they need to do something. They have their priority list. We have our priority list, based on this Moss cap. Where those priorities align is where we can make the biggest difference in the short term. And so that's really one of the ultimate objectives of a lot of the work Ben and I are doing. So I don't want to dodge the question. I can't say it's good or bad. I'd say it's in Ulster County, it's average from what I've seen. You've got some good structures, you've got some really bad ones, and then you've got a lot in the middle that could be improved, but they've held up for decades. We're hoping they can last a good while longer.
Are they generally, are we on a sustainability curve to the better? Are they generally better these days?
Yes. Oh yeah, absolutely. So, with all of this understanding, a lot of the resilience work that's been done in the last few years, especially with our increase in our knowledge of stream functions, this whole field of fluvial geomorphology is relatively new. Really starting in the 60s is when people started saying like, hey, rivers aren't just open sewers. They're not just like annoyances that we need to push to the side. So we've really learned a lot more about how rivers function, which obviously is going to improve how our road stream crossings function. Like streams are half of the road stream crossing equation. If the stream is not healthy and functioning, it's not going to be good. So the fact that we have the stream program, like up in the watershed, all of this sort of expertise around fluvial geomorphology, I think puts Ulster County ahead of the curve, at least in the state, in terms of like the projects that are going in now and for the last 5-10 years are good projects, you know, at least as good as we can make them with our current understanding. So there's definitely hope there, and some pride, really, you know, that should be taken.
Yeah, I'll add to that quick, Andy. Andy, I see you have your hand up, but yeah, as to Tim's point, the work that the Ashokan program has done, and DEP and all Soil and Water and all the local partners, what it's really given us is this intensely local knowledge to effectively implement these projects. And so, you know, moving forward, I would say that Ulster County is definitely kind of top ranked in the state in terms of being prepared, and having that baseline knowledge to kind of move forward. So, Andy, I saw you had your hand up.
Yeah, I know. I live in Gardner, and I think we've replaced 2 road crossings. The new construction in the state, are all the replacement bridges, culverts good, or have any places they haven't improved or kept it at the quality that there was? Has anybody sort of done it on the cheap, and any of the replacements not up to what they should be in the county? You don't have to name names, but
Tim, you wanna take that one?
I'm not totally sure. I do know, not in Ulster County, but I have seen some where they really didn't account for that sediment transport going through the structure. So a lot of times what people say, which kind of goes against something I said earlier, but they say, you know, just make it as big as possible. Like, right, that'll help. But there's that relationship between water and sediment, and a lot of that is based on the depth of the water. So if you make a really wide structure and you make the whole width of the structure the stream channel, the water is too shallow to move the sediment. So the structure just fills in. What we say, and there's like this saying that another famous fluvial geomorphologist has said, is like, if you have the space, don't make the stream channel wider, make the floodplain wider. So that gets into this whole thing of fluvial geomorphology, the shape of the channel, how wide should it be? How deep should it be? You know, you can predict that fairly well. If you don't stick to that, you mess up that sediment transport. So really what we try to get people to do is size the channel properly. And if you have enough space to make a really big structure, keep the channel small, but make a floodplain. Like, keep the floodplain through the structure. And I've seen some that they didn't do that. They made the channel, the stream channel, the whole length, and it was just way too wide. And then they get that aggradation, that sediment buildup. So yeah, I can't, there's not an example of that in Ulster County that I know of, but I have seen some of those.
Stu?
Yeah, just fantastic presentations, really very educational for me. About sediment, my thoughts were about sediment transport, and this isn't strictly a culvert question, but with all the attention we've been putting on the lower Asopus and deposition of sediment and turbidity issues, and it's been an interesting thought to me to think about the fact that historically, before the reservoir, there would have been massive amounts of sediment coming down, creating our beautiful agricultural lands. But now, you know, with the interruption of the reservoir, the sediment transport is really controlled by human beings and not by nature solely. And I'm just wondering how your deep knowledge of sediment transport might provide insights into the future stream management program for the lower Asopus. It isn't really only about culverts, but, you know, speed of transport, volume of sediment, predictably releasable. I just think it's a super complicated story. And, you know, whether we've got dynamic equilibrium for the most part available to us already, or whether there's a lot more that can be done through a new stream management program.
Yeah, that is a great and very complex question. But yeah, there is, I'm hoping to get involved in that Lower Esopus stream management plan effort. And I know a colleague of mine at Soil and Water who has, I said in terms of his expertise is way above me. We're hoping to be able to lend that expertise to that. There's a good point about the disruption of sediment transport from the reservoir. And just like culverts, it's doing the same thing. It's slowing the water down, all that sediment's dropping. To some extent, over the course of 110 years, is that what it's been since the reservoir was built? The stream has had a little time to adjust. So you definitely do see some impacts downstream of dams. But there's a limited sort of length as to how far downstream that effect tends to go, because if you think about it, these are networks. So even though you've got the reservoir and its massive impacts on everything, once you get far enough downstream, you have other major tributaries coming in that are providing sediment. So you eventually do get back to that sort of balance because you have those extra sediment inputs. How far downstream that effect goes, that's a big question. It depends on the size of the dam, the size of the river. But I like I said, it's a complex question. Did I answer that sufficiently?
Yeah, it's good, very useful, and there's a lot obviously to be done in the future as that plan is developed. But it seems that there's complex science, and you're pointing to the right questions, I'm sure. So yes, I think so.
Yeah, and that stream management plan coming up for the Lower Esopus is going to be immensely powerful in terms of directing funding towards projects and where the problem areas are. So that's really exciting, and a lot of folks in the sort of river community are really excited about that.
Well, one of the things about it, just a final thought on it, is the volume of water and the community release minimums seasonally. Some people have posited that there should be more water flowing down that stream all the time. Playing that off against storage needs for the city is obviously a big issue, but there might be a sustainable larger volume. Speed of transport is a big variable to figure out, which would go along with volume. And so I know that there are a lot of people who are going to be looking at that question of, do we need to adjust the minimums?
Yeah, and I'll just say, yeah, there's a lot of research going into that, because there are reservoirs everywhere, and you probably have heard about the droughts out west, and but yeah, so when the reservoirs go dry out west, what are they doing for their sort of environmental releases? So there is a lot of research going into how to manage those sustainable flows for downstream communities and downstream ecosystems. Because yeah, you need to release at least some amount of water at an absolute minimum. And what those values are and how to calculate them is a big topic of scientific interest at the moment.
Larry? He's had his hand up for a little bit.
My question is very similar to Stuart's, except I'm one river over. I'm on the Rondout and tributaries to the Rondout. And we spent some time here over the years trying to get the resources to help do a lower Rondout management plan above tidal. And when we got into that, we saw how complicated the questions and issues of river management and morphologies and so forth are. And I'm wondering how you do sort of a partial analysis, sort of factoring out the small area around a bridge when you're trying to do your moss cap prioritization, because as you mentioned, there are some alternatives to prevent flooding, such as better floodplain management and things that can be done to encourage farmers and others to not bank it up, but to let it flow in. And do you get into that? Does your MOSCAP necessarily have to simplify the world so that you can actually come up with practical decisions and what's really right, but it's not that wrong, probably, we hope. I mean, and should we not be pushing at the same time to get the not large amount of money necessary to do really good river management plans? We don't have quite the impact the New York City water supply has on the Asopus. We have more impact from God, who's more ruthless than the New York City water system. But we also have the Rondout, though, reservoir feeding in. So I'm
Right.
done wondering where river management plans for these streams comes in. We don't have them done yet. And shouldn't that be a priority for all sorts of reasons? There, I'm done. Thank you. And you make it was really a boring as hell sounding topic. Pretty damn interesting. I applaud both of you picking us. It's interesting.
Yeah, thank you. I can say one of the points, in terms of that floodplain management and the berms and things like that, the way that is captured in the MOSCAP is that alignment metric. So if we're at a bridge and we come up and we see that, somebody's basically cut off floodplain access by building a berm, we'd call that alignment channelized straight. So it's been modified in such a way that it's been straightened unnaturally. And the way the whole scoring system works is that takes off a lot of points, because it's really not good for the river to not have that floodplain access, like you said. In terms of the stream management plans for some of these, like I said, this is all fairly new. It's been being implemented in those New York City portions of Ulster and Sullivan counties. And I think, a lot of people are starting to see the benefits of it, and then starting to ask the exact question that you asked is, how do we do this for some of these other streams? And that's one of my goals. Like I said in the beginning, I've been able to take some steps out of the watershed, and one of the things we really want to do is start this stream management program, getting all of the stakeholders involved, educating them on some of these river process things that really isn't common knowledge, and trying to take some of those initial baby steps to really start managing the lower Rondout, the lower Asopus, the lower Neversink in sustainable ways.
Yeah, I've got two thoughts on that too, Larry. One is that I think it's really important to know that, Tim and I really don't exist in a vacuum. We have a lot of really great organizations that we work with, like Soil and Water and Cornell do a lot of floodplain stuff with ag and homeowners and riparian buffers. New York State's involved. You probably all have worked with Trees for Tribs, trying to increase riparian buffers. And it's a really good point about just kind of looking at your overall watershed characteristics too, when you're approaching crossings. And then my second point is, the Rondout, I know has three kind of disjointed watershed management plans. There's one for the upper Rondout, above the reservoir. There's one for the non-tidal middle portion, and then there's one for the tidal portion. I think the one for the middle I think it was finalized. I can only ever find the interim draft online, but then I think the next step would be to kind of cohesively throw all those together in a whole watershed wide Rondout plan. And I think I've mentioned this too.
You mean the lower tidal part was finalized, and the upper part feeding into the reservoir has been finalized, but the part in between has not been done.
So it's still stuck in interim.
By whom? Who's doing it?
I don't remember. I was looking at it a few months ago. I'll try to dig it up and email it to you. But the other point that I wanted to make on that note, and I think I've mentioned this to a few of you, is that given the Rondout creek watershed, as we're referring to it now, is a down dam system. A lot of the stream and watershed characteristics were really heavily documented in DEP's Water for the Future final environmental impact statement. So I can also try to send that link around. It's a huge document, but in chapter 10, I mean, there's a wealth of information on the Rondout that would easily translate into a watershed management plan.
Well, more recently, we've done the Rochester ECC has maybe started to do some work with Jennifer Farmhold too. And
Okay.
she was been with DEP and doing that. And I'm hoping maybe we can find that a fruitful link both for DEP as well as for the Rondout and all.
Let's try to get one more question from Anna, that we can wrap this up.
John, I have laryngitis.
Oh, okay.
I put my question in the
Oh,
chat.
okay. Do you take terrestrial animals? Is that the one? Do you take terrestrial animals into your accounting of priorities?
Yes. Yeah. Tim, you want me to take this one? Do you want to take it?
Yeah, go for it.
Okay, so yes, we do. So the NAC protocol has a couple of questions on: is there dry passage through the structure? How tall? What's the height of the dry passage? What is the width of the crossing when you're looking at the width of the channel or the bank full? So we're kind of getting to that answer of can animals use this stream under the road as a transportation network? And what they're doing in the future, I don't think they've released it yet, but they are releasing a whole separate protocol just for terrestrial passability. And so you can go to these crossings if you're only interested in terrestrial passage. There's a whole protocol that will kind of rank and prioritize your crossings that way. So I hope that answers your question.
All right. Well, thanks a lot, you guys. It was great. It was very interesting. Could have gone on for another hour probably. So make sure you check us out next month. It's going to be placemaking strategies for homegrown climate resilience. And in November, it'll be native plants, native pollinator garden type stuff. So thanks a lot for tuning in, you guys. Have a great night.
Thanks very much.